All right, what's up, everybody? Today we're going to talk about how to clean variables in the virtual desktop. So I'm looking here at our Canvas page. For to get started, we're going to find the instructions for the activity here, clean variables, clean bars. So we're going to open this up. And I'm going to go through these steps here, but you can also follow along and read them. So first, we're going to want to get started by going to ELSA, so logging in to the high computing cluster. We're going to go to RStudio. We're going to start a session. And we're going to log in once that is up. So just to give a general overview of where we're going to clean the two variables. At this step, you have an independent and a dependent variable for your chi-squared paper, the first paper we're working on. And we're going to be cleaning that variable today. Primarily, we're going to, when I say clean variable, what I mean is we're going to prepare it for our analysis. So the primary things we're going to be doing is we're going to be creating dummy variables for each of the categories of our independent variable and our dependent variable. We may also want to consider using the mutate variable to combine categories or recode variables. We've talked a little bit about this, but I'll talk a little bit about it, but this will be on a project by project basis. Not everybody will necessarily be combining or categories, etc. We'll talk about how the three steps of recoding, where you'll first examine the variable, you'll recode it, and then we will confirm that the recoding was done correctly. Then we'll get into phase two, where we'll create a data set with complete case analysis. In other words, we're going to go from the full GSS data set that has information on a little over 4,000 respondents, and we're going to create a data set that only has information for all of the respondents that responded to the variable corresponding to our independent and dependent variable. So we're only going that data set's only going to include those respondents. And then I may put this into, we'll talk about a little bit about how to gather the summary statistics, and I may put this in another video, but I'll briefly talk a little bit about the end of table 1 and table 2. Right, so at this point, our session is ready, so we're going to log in. Remember here that our session is always going to terminate. It's going to say unexpected, unless you logged out of your last session, you hit cancel or even hit cancel. It's probably going to say unexpected termination. Unless you log out explicitly, it's always going to give that, and it's always going to reset our R. So our environment's going to be empty every time we log in. Our console is going to be fresh. Remember our four quadrants. We have our script up in the top left, our environment in the top right, our utilities in the bottom right, and our console in the bottom left. So it's always going to be fresh when we first log in. So at this point, you should be continuing to update your template. You should have your script here, following the same format. But as a reminder here, ours always assumed everything runs sequentially. So we can't just run down here and run this table command. Going to say it can't find the object GSS. The object GSS is not found. It's not in our environment. So it assumes everything's run sequentially. Because R restarted, it expects that everything, before we run this command, everything before this was already ran. So here, our working directory should already be set. And we can see that down in our utilities, but we're still going to run this again. This command will set the working directory to your personal folder. Remember, we can double check that we have our directory. If we ever weren't sure, we can always just type get wd, and it'll tell us where our working directory is. So you can always type that to make sure that you're in the right spot. We're going to load our data here. This is going to create an object called GSS. There's the 4,000 observations and the 1,100 variables. This is just a reminder of the 3 steps where we're first going to examine the variable. We're going to recode if it's necessary or warranted, and then we're going to confirm that it was done correctly. So let's talk a little bit about this first variable here. So this is our dependent variable. We're looking at confidence in education. Remind yourself, you should have your note card should have the dependent variable written down on it. But you may have to remind yourself what the variable measures multiple times throughout the semester. So to do that, we're going to go to the GSS Data Explorer. And let's just remind ourselves a little bit about what this variable measures. So confidence in education, CONEDUC. So here's the question corresponding. I'm going to name some institutions in this country. As far as the people running these institutions are concerned, would you say you have a great deal of confidence, only some confidence, or hardly any confidence in them? So it's asking them, do you have any confidence in the people who run education in this country? And the response to the three questions are, or the answers they could give are a great deal of confidence, only some confidence, or hardly any confidence. They also could not answer. Maybe they say they don't know. They couldn't choose. They may have skipped it. They have not left an answer, or may have been inapplicable. So over 22, we know there were some folks for which this question was inapplicable. They were not even asked this question. We'll talk about this more as the semester progresses, but this will show you roughly where the responses are. And when we run this on R, we'll see each of these categories here. So we'll see, for example, that 1 is a great deal, 2 is only some, 3 is hardly any. So in our data set, 4,000 respondents, 508 say they have a great deal of confidence. They responded 1. They have a great deal of confidence in those who in the people that are running education. 1,622 say that they have only some confidence, and 629 say that they have hardly any confidence in the people that run education in the United States. So these are the frequency counts for each of these. Now, I'll talk about how we can do some recoding. Now, there's a few options we have for this. First, I'm going to show you how to make dummy variables for each of these 3 categories. So to do so, we're going to go, we can go back to our instructions for the assignment. And we could find the code. Remember, it's never cheating. Just copy code from other people, from me, from yourself, and paste it. So I'll walk through what this command is doing. This is the mutate command, which I believe you may have to actually get up the package for this, but this is the mutate command. So this is the mutate command. It's actually from a package we're gonna install in a moment here. But I'll walk through what the command does first. Where we're going to go inside the data set. This is the object where we're going to draw from the data. This is the new variable that it's going to create. It's going to create that new variable given the condition set by this if-else command, which is first we have a condition, then we have what we want that variable to be equal if the condition is met. And this will show what we want that variable to be equal if the condition is not met. So to begin here, let's go and make sure we have the package for our mutate command. So up here around line 15, it may be a little different on where your script is, but where we say settings and packages, whenever we go back and add packages, we're always going to want to add them in the same spot. Going to come back here where we're letting our packages. We're going to use the library command, which loads packages to load the package dplyr. Now, note that the first time we download, in order to load a package, it assumes that the package is already installed to our computer. So if we go to run this, it's gonna, it turns out it was actually already installed because we've used this before. The package was already installed, so it's giving you the information. The package was attached, so we loaded the package. It gave us these commands. Now, it may say cannot find package dplyr, in which case you need to make sure you install the package. Type install.packages, type in dplyr. Nope. Then we can run this command. Did I spell it right? What was it? Oh, right. It has to be in parentheses. I don't know why library doesn't want in parentheses, install does. But this is going to find this package and install it. So if you only have to do this once per machine, and you shouldn't have to do this more than once on the virtual desktop or on the on ELSA, but you may need to install if it ever does. If it ever says you can't find a package, that probably means it's not installed. You need to reinstall it. So make sure you load it again. So if we come down here now, what we want to do. So let's talk about how we can adjust this command given what we want to do. So we want to first create a dummy variable for the first value for those who said they have a great deal of education, of confidence in education. We want to have a dummy variable where someone has a respondent has a value of 1 if they have a great deal of confidence in education, and 0 if they do not have a great deal of confidence in education. So first we have to specify where our data set is. Our data set is not called dataset, it's called GSS. So where it says dataset, we're going to type GSS. Next, we want to name the category. So we want to call this something, a variable name. Ideally, it's short and concise, but also it has enough information that it can tell us what it is that we want it to, or that it can substantively explain what it is we want the variable to represent. So we want it to represent a great deal of confidence in education. So let's say high CEDU. Call one high. We'll call one. Well, actually, maybe we'll call it great. Some. Now we'll call it high, medium, low, just to keep it a little more consistent with, or just to make it easier for ourselves to remember. So this now will mean high confidence in education. So we're creating a new variable, HIGH underscore CEDU. Remember, this has to be one single string. I recommend that you name all of your variables one single lowercase string. In other words, all of these are lowercase letters. There's no uppercase letters. And how are we going to create this variable? To do that, we're going to use the if-else command, which has three parts here. The first is the condition. The second is what we want the variable to equal if the condition is met. The last is what we want the variable to be equal if the condition is not met. So let's set the condition. First, these last two parts are always going to be the same for dummy variables specifically. So this is going to be 1, this is going to be 0. Dummy variables have a value of 1 when a condition is met and 0 when a condition is not met. So we want to set under what conditions is this variable equal to 1? Under what conditions does someone have high confidence in education? That's going to be the case when C con EDUC is equal to 1. When we're setting conditional statements, we use 2 equal signs. So instead of just 1 equal sign, we always use 2 for conditional statements. So when confidence in education, this variable here, con EDUC, is equal to 1, we want high underscore CEDU to be equal to 1. When con EDUC is not equal to 1, we want high CEDU to be equal to 0. So when this condition is met, this variable is equal to this. When this condition is not met, this variable is equal to this. Okay. So you run this. Error code 403. Fun. Let's try. Oh, this is good troubleshooting. So I don't know why I've seen this error happen before on some folks, our studio, or on some folks when they're running from the computing cluster. Yep. So it seems like our the computing cluster seemed to run into an error. So what I'm going to do here is I'm just going to make sure I copy all of this script here. I'm just going to close that. I'm going to go back to ELSA. I'm going to open up another, spin up another server. I'll try connecting to this first. Yeah, nope, not going to let us do it. So I hit cancel. And we're going to start a new one up. So that'll happen sometimes if you see that error 403. You just need to restart from another RStudio server on the cluster. So it's going to have the same issue. And look, yay, it saved our script. That's good. All right. So, but remember, it did delete our environment. So we have to run all this again. Remember, everything is sequential. We got to run this. Can't find the object GSS. There's no object in our environment. We did that up here. So we reloaded our environment in. Remember, everything with we don't have to run everything that has a hashtag before it. This is just a note. Like, this is just us telling the computer we're talking to ourselves, saying hey, the hashtag hey, I'm talking to myself. This, what I'm writing, does nothing for the program. Right? Just a note. All of this, everything green is going to be a note. Or talking to each other, talking to yourself, etc. All right. So again, this is the variable. Run around this. What did it do here? Really doesn't give that um, so I did this. We're going to do a table here with our first. Let's take a look at our new variable. I'm not sure why it showed this. Usually it will not, but I think it might have been may have to reset things one more time. I hope I don't have to do too much editing in this video. But let's see. I C edu. We're gonna do a table with the new variable we just made. Yeah, that's going to not do that, of course. There we go. That's what it was. So it was my mistake. When we use this mutate command, this is just going to do the command. It's gonna create the variable, but we have to tell it where to save this variable. Every time we're saving a new variable or creating a new variable, we have to push it back into our original object of GSS. So we do that by adding our arrow here saying, use this command and use it to create this object GSS. So now when we run this table for this new variable we created, height CEDU, it's going to give us two options. It's going to give us it's going to show us what the number of respondents give value of 0 for this variable and the number of respondents give value of 1. 2,251 said 0 on height CEDU, 508 said 1. And we should expect that it's the same numbers that we saw right here. Remember, 508 respondents gave a value of 1 for the variable CEDUC. So we would want them to have a value of 1 for high CEDUC. If they did not give a value of 1 for CEDUC, we want them to have a value of 0 for high CEDUC. So our third step here is we want to confirm that these 508 here, this is a good sign, right? There's 508 people that had a value of 1 for CON EDUC, 508 people that have a value of 1 for high CEDUC. So it's looking like this is a good sign. But we want to further confirm that we recoded this variable correctly, that the dummy variable measures what we think it measures. So one way we could do that is to do a crosstab, or to look at a contingency table between high CEDUC and CON EDUC. So do that. We're going to use the table command, and we're going to have two variables inside of the table command separated by a comma. So it's going to be high CEDUC, comma, GSS, $ high CEDUC. We're going to run this, and it's going to show us the joint distribution of con EDUC and high EDUC, where each of the rows here are the values of the variable con EDUC, and each of the columns are the values of the variable high CEDUC. And each cell here is the count of respondents or observations that meet both conditions. So there are 0 respondents who have a value of 1 for con EDUC and 0 for high EDUC. In other words, there are 0 people who said they have a great deal of education for CEDUC, and we also mark them as having saying no to high EDUC. In other words, everybody who said they have a great deal of confidence in those who manage education in the country also have a value of 1 for high CEDUC, which is what we wanted. Similarly, everyone who said 2 or 3 for CON EDUC have a value of 0 for high CEDUC. They do not have high confidence education. They either have hardly any or somewhat or hardly any. So this looks like we did this correct. Let's go through and make a couple other and make dummy variables for our other categories. Remember, you can just copy paste things. You don't have to rewrite every single time. We'll call it high, medium, low. Medium, we have to set a new condition. Medium confidence in education is when CON-EDUC is 2. Low confidence education is when CON-EDUC is 3. So again, we run these two. And it's not going to show us anything. We have to confirm that we did it correct down here. So to do so, we'll do med, EDUC, low. Let's confirm each of these independently. So first here, this is a cross tab between confidence education and med CEDUC, the new dummy variable we created for the middle category, or those who said they have only some confidence in education. We see here that everyone who said 1 for CON-EDUC has a value of 0 for MED CEDUC. So no one who said they have a great deal of confidence education, or everyone who has said they have a great deal of confidence education has a value of 0 for those who had medium confidence education, the new variable we made it. And this is what we wanted because they have a value of 1 for high CEDUC. Similarly, everyone who said 2 has a value of 1 for everyone who said 2 for CON-EDUC has a value of 1 for MED CEDUC. And no one who has a value of 1 for CON-EDUC has a value of 1 for med EDUC. So we want our dummy variables to look. Same thing, confirming it for low, everything looks good. There are multiple ways to confirm that you recoded correctly, but this is one of the easier ways. Okay, so I want to show, remember here to keep updating our notation. So our step 2, we're going to first create dummy variables for each category of confidence review. For creation, and we'll do so by looking at CON-EDUC and each dummy variable. All right, so let's say we wanted to combine a category, or we wanted we wanted to look specifically, or we wanted to combine categories. We wanted to recode this variable. Let's say looking at this, we thought that we were particularly interested. Well, I guess actually in this case, there wouldn't really be a good reason to combine categories in this situation. Yeah, I can think of a good reason to combine categories in this situation, or really a way that we would do so that would be beneficial to what we already have. We already have all these 3 variables. The way they're recoded is already it's going to be sufficient here for what we need to do. Well, hopefully the next variable will have an opportunity to show how if we wanted to recode. Okay, so next we want to look at degree. Yeah, we will have it. We'll combine some categories in this next one. So first we have the variable degree. These are the values. So we can go back to our Data Explorer here. We want to find what do these numbers mean again. So this measures respondents' higher degree. So it's asking, this is based on the respondent's degree. And this looks at how much, so as a value of 0 means they have less than a high school. 1 means they have a high school degree. 2 means they have associate or junior college degree. 3 is a bachelor's, 4 is a graduate. So in our respondents, there are 417 people who do not have a high school degree, 1,019 people with a high school degree, 367 with some college or associates, 866 with a bachelor's degree, and 578 with some sort of a graduate degree. So let's get started by similarly making dummy variables for each degree. And you'll see here, you'll get used to doing this very fast. So we know there's 1, 2, 3, 4, 5 categories. We're going to be making 5 dummy variables. No high school, associates, bachelors, graduates. Remember, we have to change the condition. Under what condition do we want the variable no high school to be equal to 1? Under what condition is no high school have a value of 1 for the dummy variable? We want degree. So when degree is 0. We want high school to be equal to 1 when degree is 1. We want associates to be equal to 1 when degree is 2. And we want bachelor's to be equal to 1 when degree is 3. We want graduate to be equal to 1 when degree is 4. So never skip. As you get a little quicker and you're going through and you're able to recode a lot of these variables very quickly, you run all these, you don't see an error. Don't slow down on step 3. Don't ever skimp on confirming the creation. You can move quick through the recoding process, but be slow with when you're confirming that you did it correctly. Very easy to make mistakes. It's very easy to, for example, leave a variable, be doing a bunch of copy pasting and just leave one CON-EDUC in here. Very easy to make that mistake. So always do the confirmation. Don't slow down on this. This is an example of something here also. I don't want to make this video too long, but ChatGPT is really bad at confirmation. This is where you want to be. You want to be especially if you use ChatGPT to help you with recoding, which is again perfectly acceptable. This is the step where you definitely don't want to trust it. It does not know what you actually want it to do. It just will give you code that might or might not run. So be careful. Definitely don't skip on step 3. So we do the same thing. We're going to do our joint distribution, our contingency tables here. We're going to look at degree and no high school. And we're going to do this 5 times. So degree. Are you serious? All right. Well, looks like our server crashed again. So we're going to close our server here. Come back, cancel. Load up our ELSA again. Cancel. Oh, did I already cancel this one? Is this the new one? Yeah, this is the new one. All right, we're gonna start this new one. Oh, queued. There we go. All right, good. We didn't lose much. So, beauty of why we write script. This is one of the really nice things relative to other programs. We have to manually point and click every single thing. We already have all this stuff written down. We just highlight this whole thing here, press run, and boom, all the stuff we did earlier is still saved. As long as the script is saved, all the stuff we've done is saved. So keep remembering to save the script. You can reminder here, you can check that the script is saved. After you make changes, it'll have that red asterisk. You can press Control or Command S to save the script, or you can also go to File, Save. But you can keep you'll see I do that instinctually. I just randomly press Control S a lot, so you can get into that habit. But that's a good habit to just consistently be saving frequently. All right, so we're gonna 5 of these guys. Go through each of these steps. So our first one here. You haven't ran those yet. So you can't find these ones. We've made these variables yet. So everyone has a value of 0 for degree, has a value of 1 for no high school. That's good. And everyone who does not have a value of 0 for degree has a value of 0 for no high school. So good. High school, similarly. Everyone with a value of 1 for degree has a value of 1 for high school. Everyone who does not have a value of 1 for degree has a value of 0 for high school. Same thing. All those with associates have 1 for associates. All those without associates have 0 for associates. Same thing for bachelors. Confirm, remember, slow down with this. Make sure that this 3 is actually bachelors. If you're forgetting what these numbers are, make sure you keep going back to your data explorer, confirming that the values represent what you remember them to represent. You can even write these on your index card if it helps you to remember what the coding schema are for the variables. Okay, so this is good. Now, let's say what we're going to do here is, let's say we wanted to combine some of these categories. Let's say we really wanted to just look and we're like, there are all these different categories of folks with bachelor's degree. And what we're going to ask here in this question is, do those with different degrees have different confidence in different levels of confidence in education? So one way we could do that, let's say if we keep all these variables independent, or we use this initial variable, we're going to be looking at the relation at each degree, at each potential degree a person has, and how it corresponds to each potential level of education someone has. But let's say that theoretically, we don't really have that much reason to believe that someone with no high school degree is going to have that much different confidence in education than someone with a high school degree. Let's say looking at our literature and doing what you've read in your sociology compass article and what you've read in the other literature you've looked at, what you really think is that it's those with college degrees or those with at least a bachelor's degree who are going to be very different. Your looks to be the case that those with bachelor's degree or those with a college with a 4-year college degree or more have a lot more confidence in education than those with less than a college degree. So we wanted to create a new variable for just those that have a college degree. And we wanted to do with that is looking back at our variable degree, we want to combine whether someone has a value of 3 or 4 for degree. We want them a value of 1 for our new variable college graduate. And if they do not have a value of 3 or 4, then we want them to have a value of 0 for the new variable college graduate. So first, remember, always add notation. Any 4-year degree. So let me just copy what we did before. GSS. And let's call this all grad. Or we call it 4Y grad or something. Only like letters in my variable names. Yeah, we'll stick with college grad. It's close enough, that's short enough. Where we want college grad to be equal to 1 when degree is greater than 3. Greater than or equal to 3. Now, there's a few ways we can set this. We can say greater than or equal to 3. We can also say greater than 2. Greater than 2 is the same as greater than or equal to 3. We can also write equals 3, or use or by this straight up line here, or degree is equal to 4. There's multiple of these options. This or command will allow you to set even if they're not all the same. And I'll show what that means in a second here. But well, I'll actually show that in a moment. But let's take a look and show and do this one first. So this is saying create a new variable called college grad, where it has a value where if the degree is equal to 3 or degree is equal to 4, then college grad should have a value of 1. If degree is equal to 3 or degree is equal to 4 is not true, then we want college grad to be equal to 0. So we want to confirm that's correct down here. On this. And we can see this is the case. There's a value of 3 or 4 for degree, have a value of 1 for college grad. And those who do not have a value of 3 or 4 for degree have a value of 0 for college grad. Let's say we wanted to combine those at the extremes. And this may not make sense theoretically, but I'll just show why the or command rather than just the greater than can be beneficial. Let's say we wanted to combine. We want to make a variable for grads and no high school. Wanted to combine these two folks. We can set this, our or commands, to be if they have a value of 1 or 4 for degree. So if they have a value of, 0 or 4 for degree. If they have a value of 0, they have no high school degree, or they have a value of 4, they have a graduate degree. We want them to have a value of 1 for grads and no HS. If they do not have a value of 0 or 4 for degree, they want to have a value of 0. So we can then look at that. Make sure you run this. Let me see here. Everyone has a value of 4 or 0. The value of 1 for grads and no HS. Everyone has a value of 0. Who does not have a value of 0 or 4 for degree has a value of 0 for grads and no HS. So this variable doesn't really make sense theoretically, but at least now you're able to see some different ways that you could do some recoding. Okay, so congratulations, we've now recoded both of our variables. You should create a new dummy variable for all of the categories of each of your variables. Everyone at this point, both their independent and dependent variables are qualitative or they're categorical. But you want, for our chi-squared test, we're going to want to, well, we're going to look at the relationship between two categorical variables. So you are going to want to, if you have a quantitative variable, then you would also want to make sure you recoded that into a categorical variable as well. Okay, well, in phase 2. So we come back to our instructions here. Remember, if you have it saved, I did it instinctually. Notice here, there's no change here, right? So make sure you're saving. So under our phase 2, or instructions, we're going to create an object called my dataset that only includes variables or observations with complete case information for those variables. Otherwise, there should only be columns for your independent variable and dependent variables, and rows that have a valid response for your independent variables and your dependent variables. We're going to do this in 3 steps. So again, we're going to always follow along this template. I give you these notes. The green are notes, right? These are notes. I give you these notes not to help guide you as you're writing your script. So we're going to create our data set. We're actually going to call it, I'll leave it like that. We're not going to call it, just to make it what do I ask you to call it here? I do ask you to call it my data set. I'll show what that means in a moment. Instead of changing this, we want to keep our notes in substantive. Okay, so first we want to create a list of variables that we want to keep. Here's how we create a list. We can copy that command here. And our RStudio broke again, so let's close it, cancel. Start a new session. Nick. Rerun everything down to here. And this is also a good time. It's actually a good time for this to happen because we want to be able to confirm that everything in our whole first phase, where we're doing a pre-analysis, everything in our first phase, we're cleaning the data, should be able to run with no errors. Should be able to highlight all of this and press run, and everything should work. Scroll through and everything should still look the same. You can even go back through and don't forget to double check your cleaning still working. All of our variables are still properly cleaned. Our dummy variables are properly created the way we wanted them. So next we want to create a list. Do so like this. We're going to make a list where every variable we want is included in this list, separated by a comma. So we want our CLN EDUC, comma, high CEDUC, comma, med CEDUC, comma, low CEDUC. So that's all the variables made up here. So include all the dummy variables you made as well. Now I want to get a list of all of the degree variable and all the dummy variables made for degree. Remember here, one thing we could do, we want to separate things, we can separate things on the next line, or we'll keep going until the command is over. So if you want, so if you press enter here, see how it indents here. This actually doesn't have to be indented, but it will automatically do it. And this is how I recommend that you write your script, to say that all of this is actually just one line of command. We've seen some examples of this earlier, but none in the script currently. All of this is just one command for my var lists. Kind do you see? How do you see? So what I recommend you could do is put all the variables corresponding to each overlying variable. So all the variables for confidence education on one row. We'll do the variables for degree on the next row. Comma associates, comma batch, comma graduate, comma college grad. It's a good time to notice this, especially since we're typing in like these parentheses. If you have an extra parenthesis or something like that, it'll give you this warning. Unopened bracket or unopened unexpected token. Usually when you see something like this, it's because you have either your parentheses aren't in the right spots, something's not closed, or your quotation marks are not closed. So in this situation, there's an extra parenthesis. So it actually thinks that this is a string right here. That's an open and closed parenthesis, and it's confused. It's like, what do you mean? You didn't even tell me what's supposed to be here. So it's confused. So just it's one way you can troubleshoot. Okay. So once you have this list, we can run this list. We'll see it up in our environment. We're gonna have a list of our variables. There's 11 variables in this list, 11 strings in this list. So next, we use this command here. We're going to create a data set called my data set. Only your variables and complete case information. So we're going to use the select command to only limit the data frame to include variables that are in the list my var list. And we're going to use the filter command to limit the observations to only those that meet the condition of having complete case information. This pipe function, or this I don't know why I call it function. It's not a function. This pipe here, which is the oh my goodness, I'm forgetting the word for that. Percent sign. Oh my goodness. Greater than sign, percent sign. This is a pipe. This means continue on to the next line, or go with continue on to the next line. The command on the next line is part of the same command. It should all be ran continuously with the command on this line. Just saying, take the variable, the dataset GSS, select all of the variables inside of my var list, all of the variables inside my var list, and then given that, filter out so you only have complete case information. I only want variables. I only want observations for which we have information on all of the variables in the data set. So we highlight this and press run. This actually good note here because it says it can't find the variable graduate, and this is a good so I'll show you how to find this error here. It says element graduate doesn't exist. I wonder why the variable graduate doesn't exist. So we go back up, we can find where we made the variable graduate, and we can see I can't spell, and there's an A missing right there. So always rerun everything again. Now we have the variable spelled correctly with graduate. We also need to recreate our variable list. It's a good general troubleshoot rule. Run everything. And right here. And now we have our updated data set, our complete case data set up here in our environment. So in our initial GSS, there are 4,149 observations and 1,100 variables or so. In this updated data set, there's only the 2,758 observations. So these are the number of observations for which we have valid information for all of these 11 variables. So now when we click on this, we actually have a much, it's a little more manageable data set to look at. So this is the first person, this person right here. They have a value of 3 for con EDUC and 3 for degree. And this is another place we can verify that our dummy variables are coded correctly. They have a value of 3 for con EDUC and a value of 1 for low con EDUC, and 0 for high and 0 for net. So this is further evidence that our dummy variables were created correctly. Similarly, so the bachelor's degree also has a college degree. They have value 3 for degrees. This person has hardly any confidence in education, and they have a bachelor's degree. This person has a great deal of confidence in education, and they have no high school. Okay, so back here, don't forget, keep saving. On to our last step here. So there's actually nothing, you didn't have to change anything in this command here. All you do is copy and paste it directly from Canvas. All right, so step 3, we're going to gather some summary statistics. There are multiple ways we've learned to get summary statistics. You can use the table command, you can use the summary command, you can use all the other commands that we've gone over, you may have gone over in previous classes to look at descriptive statistics. But one convenient command is the describe command, which comes from the package psych. Reminder here, new packages, we always do it at the beginning. So we come back, we always add all of our packages back here. We always spell library with an R. We run this, and I guess we did already work with psych before as well. But reminder here, if this doesn't work, you may need to install packages by typing in that. Don't forget the parentheses when you're installing. Okay, so then we're just going to use the describe on here. One thing we really want to confirm here with my data set is that all of these variables have the same head. I'll talk about how to interpret all these values in the next video on descriptive statistics tables. But one of the main things you're looking for at this point is that you have all the ends are completed here. Okay, and that is a short tutorial on how to clean variables. You can continue following along with trying to begin the descriptive statistics tables. Here are some of the instructions. If you open up these templates, you'll find more instructions. But I will make another video on these two tables and where we're going. But congratulations, and thank you for your time. Please let me know if there's anything I could do to make these videos a little more informative or more helpful. And I look forward to getting your feedback. Thank you and stay safe. Bye.